Stanford University.
You may notice that your lecture is a little different today. Hi, my name is Andy Matuszak. I work on the UIKit team at Apple, and Paul has graciously allowed me to take over one of his later lectures. And I'm here to talk about a topic that I do my best to evangelize near and far, and I'm going to do my best to display these concepts today in the least evangelical ways possible. So we're going to talk about testing. And testing is sort of by its base nature an incredibly boring topic, I feel. It's like a chore, it's code cleanup, it's like documentation, it's like a lot of these tasks that you just don't want to do. But I think there's a lot of really great benefits to testing beyond even just reliability and confidence. But those reliability and confidence benefits are pretty key. And I think that sharing a really embarrassing story would be a nice way to kick this lesson off. So we've got this thing in iOS where a view can be opaque or not. And all that affects is whether or not the pixel buffer that's underlying that view has an alpha channel. So you get 25% more bytes for each view if you mark something as being non-opaque, because then it needs to store the alpha values for every pixel. Now, if you've got a view that's full of opaque contents that is nonetheless marked as non-opaque, you're wasting a ton of memory. But it's not obvious that you're doing it, because when you look at the view, it looks fine, and your app isn't crashing due to memory consumption. It's just taking more than it should. So you don't really notice it. And so this was going on for a while, and we didn't really notice it. And fine. So then somebody saw it, and I fixed it. And all was well. All was right with the world. And then a few months passed, and we did something somewhere else, and this problem returned, where these views that were full of opaque content were being marked as non-opaque. They were taking up more space than they should, and nobody really realized what was going on. So I fixed it again. And then recently, in certain cases, it turned out that, well, it's happening again. So that's great. And it's really embarrassing. And it does a number of things. First off, it reflects poorly on all the engineers involved, so that's not so great for me. But also, it's not so great for the performance of our users. It's not so great for our confidence when we're changing anything around here. We're going to be sort of walking on eggshells, and for good reason. And perhaps worst of all, it's indicative of sort of some underlying architectural problems that were terrible code smell. And those problems were leading to these surface syndromes. So what should we do? We should test. It's really easy to just say, well, this view that I have should probably not be marked as opaque because its contents are filling every pixel. Fine. I can write a little robot that will sit there and verify that assertion all the time, every time we build, every time anybody checks anything in. And then hopefully, this mistake won't happen again. So how are we going to go about doing that? There's a couple approaches. Say that this is an app, this is a Zookeeper app, and it's the one that we're going to be working with today. And the Zookeeper app has a list of animals, and then it's got a little editor for each animal. Maybe it's got a share button. The controllers are in pink, as is the convention. And then there's models for the zoo, for the animal. And those are shown in blue here. And as we're developing this app, there are a few different ways we could go about testing stuff. We could test it sort of from the user's perspective in a really top-down fashion, where we say, OK, robot, you're gonna launch the app, and you're going to press a bunch of buttons, and you're going to make sure that the screen looks as it should look. That's sort of a top-down approach, and that's more or less just automation. And we're going to be covering that later today, and specifically it's UI automation. We're pressing buttons, we're seeing things happen on screen. Another approach is to go from the bottom up and to say, well, let's take the zoo, and let's make sure that when we add an animal to it, it's actually appearing in the zoo roster. When we set the animal's name, it's actually appearing to be appearing to be its name when we ask for its name again, and silly little simple things like this. And we can actually do our best to separate those low-level components when we test in this bottom-up fashion so that we're testing in the most granular way possible. And this lets us develop incrementally, and this makes sure that our pieces verify their individual contracts before we start hooking them together. And top-down testing will verify the way that they hook together. So this bottom-up testing is unit testing, and we're going to be dealing with that first. I think, though, that there's a few other benefits, though, to these testing ideas, because essentially what we're asking you to do when we say, you should probably unit test your code or write some tests for your code, is to specify your expectations, to specify, like, what do you want from your program? And that's probably a good thing for you to have specified anyway. Because if you specify these things explicitly, then you get a number of nice benefits. You get stuff being modular, sort of by nature, because if it's clear how every single class in your system, how the animal should be used when you send it messages, what its responses are going to be when you ask it things, then it's way easier to develop a new feature around the animal. It's way easier to maybe add new kinds of animals, things like this. I think that it encourages intellectual honesty. So it's really, really hard to just like implement some new feature and look at it and say, oh, it's done. And maybe you have some hint in the back of your mind that this little corner over here, this corner of code is kind of suspicious, but I haven't poked at it very much. And so the tower, the Jenga tower hasn't fallen down yet. And so maybe it's OK. We're going to commit it. We're going to ship it. We're going to go on with our lives. I don't think that's, in general, a great strategy to have. And so if you're in the business, if you get yourself into the business of writing down your expectations and your assertions, then I think it encourages you to be honest with yourself about the state of your system, about how reliable things are, and so on. Perhaps the most important thing that this buys you, though, is a little more confidence when you're making architectural changes. So say you've got the animal class and you've got the zoo class, and you're making some big changes to the UI above them. If you have a bunch of tests, then if you break something while you're making those big changes, you're redoing your UI, you're probably going to hear about it. Now, it's not a guarantee. It's not a guarantee, but you're more likely to hear about it. It's more information. And that is a great thing, because then you're less likely to release broken code. You're less likely to go hours down the wrong path. And you're more likely to just understand the state of your system. But talking about likelihood here, I think, is important, because the goal here is these goals. The goal here is the confidence and the reliability and the intellectual honesty and the good architecture, not just to write tests or just to have your unit tests cover every single line of code. That isn't directly useful. So I say, let's take kind of a pragmatic approach. Let's use things where they make sense. And I'm going to kind of try to demonstrate that with a little app over here right now. I want to show you guys a very exciting piece of software. So we got the Zookeeper app. Let's check it out. We've been contracted by some zoo somewhere to make an app that keeps track of all of their animals. Right now, though, it's a really small zoo. They've only got one animal. His name is Roy Roarington. So you could, like, I don't know. Maybe now his name is Roy the Lion Roarington. But I have written this very beautiful app for our client, and I have given it to our client, and he had nothing but glowing words from me. But this client, he's got a small zoo. He's a new zookeeper, so he's trying to distinguish himself from his peers. And so he looked at this app and he said he loves it, but got just one request. I think that all of our animals should have salutations. Really, it's not Roy Roarington, it's, His Majesty Roy Roarington. Perhaps it's Sir Roy Roarington or Colonel Roy Roarington. I think it's really important that our zoo be full of animals with proper salutations because we should respect them for the wonderful and beautiful creatures that they are. And so I say, okay, we can do that. We can add a salutation thing. That's fine. So say I'm going to go ahead and add this feature. There's a couple steps that we would need to take. Let's start by breaking it down. We've got some animal class that's keeping track of the details of Roy Roarington. I'll show it to you here. Roy Roarington knows what zoo he's in. That's nice. If he gets lost, he can maybe return home. He's got some names. And there's a convenience method here to get a formatted name that's suitable for display on screen. Like it'll put a space between first name and last name. So clearly we're going to need something here to store the salutation for Roy and his peers in the zookeeper's zoo. But also we're going to need some UI changes, right? We're going to need a little field in that editor for the salutation as well. And that's going to need to be hooked up. And when you change it, it's going to need to change the title, just like how this is changing the title here. There's a fair amount of complexity, and it needs to save as well when you leave, so that when you go back to the list, this also has the proper name. And I think that it wouldn't be a great approach to just charge at this and do all of these things at once. So one advantage to exploring testing and automation is that we can actually make this change more incrementally. If we were to approach this feature by doing all of the things that I just described all at once, we wouldn't actually be able to see whether anything was working until we got all of it done, really. For instance, if formatting the name turned out to be kind of tricky, we wouldn't know it till the end. And that's not a great situation to be in. So maybe let's do this a little more incrementally. One advantage of the automated tests is that, well, they're run by a machine, and so they can deal directly with the model classes. They don't need a pretty interface. So how are we going to do that? Well, what do unit tests look like? How does any of this work? How do we write automated tests? This project is extremely complicated, as I said. There's a lot of moving parts here. So I want to show this to you with a simpler project first. Let's just look at like the default Xcode template, or how to make a project that involves unit tests, because that in itself is a little tricky. So we make a new project, say an empty application, and then all you have to do to get unit tests is make sure this box stays checked. If you can do that, you've got unit tests. That's all. So tests, say. And if we make this project, we have the box checked, critical step. Now we get this group over here called tests, because of the tests for tests. And we see a couple source files. We could start to explore them. There's some supporting files. And there's still just this one scheme. Fairly simple. Xcode does all the work for you. This is really the easiest way to get started. It's certainly possible to add unit tests to a pre-existing project. There's just some fiddly bits that I don't think it would be too productive for me to show you right now. If you look up the documentation, you can find the 10 steps to add unit tests to a pre-existing project. But for now, I want to whisk you back to the land of the Zookeeper app, now that you've seen how to create a new project that involves unit tests. Hopefully, you'll use it for your next one. And let's look at the Zookeeper tests, which are also empty, because we've done an excellent job with our tests so far. So we got this group here, Zookeeper tests. And inside of it are two source files. Same name. Fine. Nothing too interesting in here yet. We've got this test example that has stfail, unit tests are not yet implemented in Zookeeper tests written in it. This is essentially the hello world equivalent of unit tests. This is the unit test system saying, hello, these tests are broken. So how do we run them? Well, we can just say product, test. It's right under run. That is the importance level of tests. I guess it's more important than performance? No, not actually. OK. The simulator can't be launched because it's already in use. Thank you, Xcode. Product test. And we will see our tragic failure here appear on the left as magic. You'll see also this line is highlighted as if it included a syntax error or some kind of logical error. No, this is a testing level error, and it joins its peers in showing you where you have screwed up. So here, you've screwed up insofar as you haven't removed the one line that comes with the Xcode templates, which makes the test fail. So this is an example of what a test failure looks like. That's kind of cool. What does a test pass look like? Well, we could do stfail. What's sort of the equivalent? Well, we can say, let's assert that true is true, and have the same sort of message. And let's make sure that this still passes. So product test. And now we see this pretty little test succeeded. And that is the gold standard that you're looking for from now into infinity. As you write your code, you're going to compile it, and you're going to look for build succeeded. And then you're going to press Command U, which incidentally is a shortcut, become friends with it. And you're going to wait to see test succeeded. And then you're going to smile, knowing that you have slightly more confidence that you haven't broken everything. If you wanted to be really special, you would then run this Clang static analyzer and see analysis succeeded or what have you as well. And then you'd have even a little more confidence. So fine, we've got one test that does nothing, and it's useless. That's not very helpful to us. Let's do something else. Let's do something useful. So we said we were going to add the salutation property to the animal. That's how we're going to start. I'm going to open them up side by side so that we can edit our tests at the same time we're editing our animal. We see first name and last name. It seems fairly straightforward that we probably want to have this be joined with its friend salutation. So we've added this salutation property to animals. And now maybe we'd like to say that, well, when I set a salutation and I ask for the salutation, I get that same thing. So I'm going to go back to my test, and I'm going to write a test that asserts that. How do I do that? How is any of this working? Is a reasonable question. The answer to that question is kind of shenanigans. This class, Zookeeper Tests, is a class that inherits from sendTestCase. So that's significant. That's number one. And number two is that this code here, this stassert_true, is inside of a method called testExample. So what this testing suite does when it runs your unit tests is it goes through your project and finds every class that inherits from sendTestCase. And then it finds all the methods in each of those classes which begin with the word test. And then it runs all of those. So if we want to add a test, all we have to do is make a method in a class that inherits from sendTestCase that starts with the word test. So test, salutation, equivalence or something. That's fine. So again, what we want to ensure is that if I make an animal, and I'm going to have to make a zoop. That's fine. And I set his salutation to be sir. Then when I ask for his salutation, I get sir back. You'll see that this third parameter here is a description of the assertion. You can pass nil if you want. But sometimes it's useful to have a little message for your poor replacement down the road who's looking at this failing test and wondering, why was this even supposed to work in the first place? Cool. So we made an animal. We put him in a zoo. We set a salutation. Now we're going to assert that after we set a salutation, his salutation is still sir. Not terribly interesting. You'll note that I used this function here called stassert_objects, which is not actually a function. It's a macro. And this is one of the ways that we express those expectations that I was talking about earlier. What do you want from me? Well, I want you to save the salutation. OK, we do that with these assertion macros. And there's a bunch of them. And you can find them in the Sen testing framework, Sen testing kit headers. This is in the Sen test case macros header. And here's a simple list here. So we can just fail immediately. We can assert that an object is nil. We can assert that it's not nil. We can assert that a Boolean expression is true, et cetera, et cetera. One thing to point out is equals and equal objects. Equals is for plain old data, ints, chars, bools, that kind of stuff. Equal objects is for Objective-C objects, instances. And it uses the is equal to method to compare them. So back to this. If we were to build this, we get warnings. That's not looking so good. Now our test succeeded, and that's not looking so good either. Why did it succeed? That's always fun. So I think it's important when writing tests to write something that should fail as well as something that should pass. We just wrote something that should pass, and for some reason this passed, even though we haven't actually synthesized the salutation method. So that's a little concerning. Maybe we should write something that should fail. We'll set its salutation to Mr. And then we'll assert that its salutation is still sir. And I'll just pass a nil description here. Now what do we see? We see a failure. So things don't seem to be working right, and that's because we haven't actually synthesized the salutation property, as you'll see here in the build messages. It's simple enough to resolve. We can just add it to our little list of synthesized properties over here. Pardon me as I run out of space. And now this should fail happily. Indeed, Mr. should be equal to sir. Well, we don't actually expect that. This test is a lie. So that's an important thing as well. Some tests are lies. Maybe you've written some code. You've written some tests for that code. You change the code. The tests start failing. That could mean that your change is broken. That could mean that the test is a lie. It's important to keep these things in mind. Now, this test right here is a lie. We could make it a useful test by saying stassert false, that these things are actually equal. And then if we were to run it again, Command U, we get build failure is equal to string. Dangers of coding on stage, ladies and gentlemen. And now our test succeeded. And this is an incredibly boring test because all it is tested is that the Objective-C property system works. And if the Objective-C property system isn't working as you expect, then you have worse problems. So let's maybe test something a little more interesting. How about that formatted name method? That's kind of a useful method, and it's probably the next thing we're going to have to deal with. We've added the salutation property. What's up?
Why did the first test pass?
This test? This test passed because we're doing it right. So we've got a salutation property, and we've synthesized it to be equal to an IVAR. And so if we call set salutation, it'll actually save that. Is that?
In the beginning, you didn't have to set the synthesize.
Oh, OK. Because it was throwing, and that's actually a good question. Why did it pass? It should not have done anything reasonable at all. It should have thrown an exception. And it's possible that an exception is getting treated as a pass, which seems like a bug to me, which is untrustworthy, which is why I wrote the second test. And then when the second test also passed, even when it should clearly have failed, I knew that something was up. And then I did this thing, and then things started behaving sanely. It's true that if a test throws an exception, that should probably count as a failure. Although it's probable that you have to actually explicitly specify that you want that behavior by using stassert throws, stassert no throw. So that may be what's causing that. That's a good question, though. And thank you for calling me out on that. So we've got a salutation property that's terribly boring. What's the next thing we have to do? We have to make it so that that pretty little navigation bar displays Sir Roy Roarington when we set a salutation to Sir. Fine. We do that with the formatted name method, which takes the first name and last name and glues them together with a space, and you can see it right here. And its structure is pretty simple. We've got like this simple little name components array, and we don't know which of these properties is going to be nil or not, and we want to still do a decent job of formatting the lion's name, whether or not he has a salutation, whether or not he has a last name or a first name or whatever. Like, so if the lion only has a first name, then his full name should just be the first name. It shouldn't require him to have a last name. And if he only has a last name, his full name should just be the last name. And if he doesn't have a salutation, then the formatted name should still work OK, and so on. So that's simple enough for us to execute. But let's write a test for it first so that we can sort of establish a baseline. So let's do test salutation formatting. Simple enough. We'll go ahead and take this animal. And let's give him a first name and a last name. First name, Bob. Last name, Cat. Done. OK. And now we're going to give him a salutation. Duke. And we want to ensure that his formatted name, animal formatted name, is Duke Bob Cat, because that's what we're going to want to see in our UI. But if we run this test, it's not going to work because we haven't written that code yet. So we got this error saying Bobcat should be equal to Duke Bobcat, and it's a terribly small error. I hope you can maybe read it. Might be easier to read over here. That's a pretty useful little error message, and it gives us some nice guidance as we make our changes. Essentially, we'll know we're done when we press Command U and we get a little happy face. So let's go over here. And if we have a salutation, then let's add it to our name components. Let's give that a shot. Test succeeded. Go us. We win. Now, we're not really done with this test yet, because if we hadn't been very careful, like if we just did this, then this test would still pass. Then this, the other test would fail. OK, fine. But that's pretty bad, right? We want to catch that. So we should write a test for the original case, too, the case where there is no salutation, the case we've been having all along. So when you make a change, it's nice to write a test for the current state of the world as well, so that you know that whatever apple carts are already on the road are not disrupted by whatever you're doing. Formatting without salutation. Let's do that. And we can basically just take the same test, but without the salutation, and assert that then we get Bob Cat. And there will be an interesting question here of whether the program crashes first or whether the test fails. But it's certainly possible to do this in such a way as to make the test fail before the program crashes, or worse, have the program not crash at all, and you just have a logic error, and you go on with your life with a poorly formatted animal name in your zoo dossier, and you'd be very, very sad. So we've got this test, and it's a happy test. And if I undo the intentional breaking in formatted name where I guard with the salutation, then we should see things working. And indeed. So we tell our client, we've got the beginnings. We've got the beginnings of salutations working, and that's wonderful. And he says, that's great. So like, what's the UI going to be like now? You've got the model bits going. What is your UI going to look like? And I say, well, I figure it'll be a text field, right? So that the user can type in like whatever whimsical name he chooses. And suddenly my client looks very, very grave. And he says, no, you think this is about whimsy? No, this is about honoring the animals. We can't be giving them nonsense salutations. These have to be legit vetted salutations. You can't have like unicorn fairy Roy Roarington. You have to have sir or Mr. or some salutation that's acceptable in common society, because this is how we want to honor the animals. And I look at my client a little funny and I say, fine, which means we now have a validation issue. What's that going to look like? Well, we have to have a list of permissible names. Maybe we'll load it from a disk. Maybe we'll get it from the network. But whatever we do, when you actually go to set a salutation on the animal, at that point, you don't really care where those names are coming from. Could be from disk, could be from network, whatever. We're going to get them from the zoo. The zoo is going to be the harbinger of the permissible salutations. And the animal's going to ask the zoo for that list. And then we're going to verify that the salutation that you've chosen is actually in that list before we allow you to proceed. So let's start with the zoo. A zoo has a list of permissible salutations. Salutations. And let's just pick a few. My tiny class, give me some examples, please. Yes, majesty. What did you say? Lord. Lord. One more? Princess. All right. That's good. I'm pleased with that. Thank you, my tiny class. OK. So we've got this tiny list of permissible salutations. And what are we going to do before we proceed? Let's write a test for it. Let's write a test for it. Now, this file is starting to get a little unseemly, and we could do something about that. I'll show you in a moment. So if we just make a zoo, a plain old zoo, let's make sure that it's got at least one salutation. This is an example of a test that might end up not being true in the long run. You know, it's possible that you might have a zoo that doesn't permit salutations. But this is an example of a sort of situation where I'm probably going to code assuming that there's at least one salutation elsewhere. And so if I ever encounter a zoo that doesn't have any, I want a heads up. Because that's probably, that's one of those intellectual honesty, like there's some sketchiness there. I want to test that more thoroughly if we ever find a zoo like that. So for now, let's say that a zoo always has some salutations. We don't get autocomplete, apparently. And our test succeeds because it's incredibly boring. But I'd like to show you something slightly more exciting before we move on, because I am bothered that we are testing a feature of the zoo here and a feature of the animal here. My organizational OCD does not allow for this. And I think it's nice to separate the bits that you are testing into different areas so that you can see in this lovely report that you get your test areas segregated. Which area usually has the most problems? And then you can go blame that engineer. You can be very upset with that engineer, him or her. So how are we going to do that? Well, I was saying that we just find all the subclasses of send test case, and we use those as tests. So let's make another subclass of send test case. Real simple. And it turns out there's actually a template for that, which is pretty cool. So this will be zoo tests, and we'll call the other one animal tests. I will try to use the rename refactoring thing to do this. Whoa, it worked. OK. And then let's move this guy over to the zoo tests. Oh, dear. In order to make this work, we're going to need to import the zoo. And you'll want to verify that this file is built into your test target. So you see right now that it's built into the app target, which is not especially useful for you. You would like to be part of your test bundle. You'll see that by example, the animal tests are. So fine, let's run this thing. Build succeeded. Test succeeded, and there was much rejoicing. So we've got a list of permissible salutations. And now we want to do that thing where if you try to set a salutation that's not permissible, we throw an exception at you. We're going to use that thing that I introduced to answer your question a moment ago, st assert no throw, to make sure that we're doing this reasonably. Throwing an exception, by the way, may not be the best design for this feature, but it is expedient in this case. And so, as a terrible example, because we're not talking about proper error handling, we're talking about testing, I'm going to do it. But thinking a little bit about how my implementation is going to work as I code for you on the spot. I note that the animal has a weak pointer to the zoo that it is in. And in order to verify that the salutation that I've given it is permissible for the zoo it's moving to, like maybe it was in the Brooklyn Zoo, and they're cool with like sir and lord, and then I move to an Italian zoo, and they only permit Italian language salutations, I will need to ask the zoo that the animal resides in for the list of its permissible salutations. And that's a little interesting from a testing perspective, because it may be in a different zoo. You'll note that in our tests so far, we're making a zoo for each test. Like, is the default list of salutations a good one to test? We don't exactly know. Maybe it's loaded from disk or from network. And so we might get confused if later the test got changed out from under us. Like it could be reasonably loaded from a plist, and then the list of salutations change. You may remember that I was talking earlier about testing little bits at a time. And that's part of where the unit name comes from. But part of that testing little bits at a time philosophy is trying to test the components in a separated fashion. So the animal has a back pointer to the zoo, and it's going to ask the zoo for some things. But we don't really want to depend on the zoo's implementation of the permissible salutations for our test. We're only testing the animals in this class, as you can see by its name. We're not testing the zoo, or at least we're trying to do that. So in order to accomplish this, I will make a fake zoo implementation, a subclass perhaps of AMZoo, which overrides this method and returns a known result that's defined here in the test so that I can test against that known result rather than testing against whatever the implementation of zoo happens to be. Then, if some other guy goes and changes the implementation of zoo in a way that doesn't break my tests but would surprise my tests and make them fail, I'm not going to have to go through the churn of going and fixing the build. So, how are we going to do this? Well, mockzoo will inherit from AMZoo, and it will override the list of permissible salutations to only contain test. That way we'll know that we're getting this fake list because no zoo would have that salutation. And then when we go ahead and do our test, we can create our animal and put him in that zoo, and we'll know exactly what salutations are permissible. So to write our test, test salutation strictness will make a mockzoo, and we'll make an animal, and we'll put him in the mockzoo, and it was zoo mockzoo. And then we'll try to set the animal salutation to test. And that shouldn't throw, but it should throw if we set the animal's salutation to Lord? Because that's not in the list of tests that we've just defined here. So we've kind of tightly coupled the test with this one particular implementation, which is nice. Sometimes it's not so nice, because if you do this too much, if you override too much behavior, then you can start getting confused. But what we're trying to test here is not the zoo's response. What we're trying to test here is the fact that set salutation throws when you give it a salutation that its zoo does not support. So we don't care what shenanigans that method does, the permissible salutations method on the zoo. All we're trying to do is test the set salutation method on the animal. Hence, we've made this little mock zoo. OK, of course, none of this is going to work. And we get this interesting false positive here because it doesn't throw when we set the test salutation. Why should it throw? We haven't made anything throw. But of course, we've asserted immediately below that it should throw when we try to set salutation to Lord. And so that catches the fact that we haven't actually done any work for this feature whatsoever. So now to go do the actual work, i.e., set salutation to. OK. If the list of permissible salutations that we receive from the zoo does not contain the salutation that we've been passed, then we're going to throw an exception, raise an invalid argument exception, saying that it's not a legit salutation in this zoo. Otherwise, we'll go ahead and set our salutation to the one that we've been given. And that is under zoo. And you would want to know that that is actually a method. OK. All right. Now we've got two issues. Why do we have two issues? Let's find out. We've got a test failure, test salutation equivalence, and test salutation formatting. Aha! This is actually sort of legit. Because in these earlier tests, we picked a salutation that our zoo doesn't support. Recall when I asked you kind people for lists of salutations in the normal traditional zoo, you gave me Majesty, Lord, and Princess. But here in these earlier tests that we'd already written, we had chosen the salutation Sir. And down here, we'd chosen the salutation Duke. So this is an example of where if you're not careful about just how much you're testing, somebody going and changing something behind your back can get you in trouble. These tests did pass. Now we've made them fail. And that's unfortunate. If we were to do the obvious thing here, which is, well, the test should, because we're not using a mock zoo, we're just using a normal zoo here because this test already existed and we don't want to change much. If we were to just change this to Lord, this test would then pass. You'll see there's just one over here in a moment. What was that? The next line. You are my hero. You will see that the remaining fairly. This line. Yes. False. OK. We're actually still getting an exception, which is interesting. Teamwork, ladies and gentlemen. Let's figure it out. That is a terrible error message. Unknown.m, line 0. That is not a legit salutation in this zoo. It's possible that we have messed up our implementation, and by we I mean I, of am animals set salutation here. Contains object. It's also possible that the tools are being finicky, and I will give up shortly so as not to waste more class time with these finicky shenanigans. let's not worry too much about that. I will wave my hand and gloss over that for now, in the name of teaching you all of the things that I want to teach you. So what we just covered was the idea of a mock, making it so that you can have sort of known situations for other objects, so that other objects changing out from under you don't affect tests that you have from their peers. That's a lovely thing. It's a lovely thing when you do it right. When you mess up the tests, or Xcode confuses you, as is happening in this lecture apparently, it's not such a lovely thing. But let's gloss over that for now. Now, we've got some UI to do, but that actually turns out to be a fair amount of work to do the whole picking interface. So I'm going to go ahead and switch to some code that has that. And then we're going to test the whole top-down approach, now that we've looked at the unit test bottom-up approach. But before we do that, I would like to really quickly review some of this unit testing stuff, because I've been just making with the typity-typity at Xcode, and there haven't been slides. And I know that those of you who aren't here would probably appreciate a sort of condensed form of this rather than watching me yammer and type for an hour. So to review briefly, to make a test suite, all you have to do is define a subclass of sendTestCase. That will define your test suite. It's nice to make one for every sort of area of your program that you're trying to test. We had an animal test suite and a zoo test suite. Those will be tracked separately in the logs. They'll appear separately. When you run your tests, you can choose which suites to run in Xcode Scheme Editor. I didn't have time to show you that, but check it out if you have a chance. And then all you have to do is for every unit test you want to define, you make a method that starts with test. You can make these methods really short, really sweet. And the unit testing framework will run all of your methods in your sendTestCase subclasses, which start with the word test. Pretty simple. And in those methods, all you have to do is say, what do you want to see? Well, when I set the animal's name to Bob, and then I ask for his name, it's supposed to be Bob. When I try to set the animal's salutation to Lord, but we're in a French zoo, then that doesn't work. Those are my expectations. I'm going to state them. You use these stassert macros, and you can see all about them in the headers and in the sendTestingKit documentation. There's one thing that I didn't quite get to cover with the sort of interactive overview that's worth briefly mentioning, and that's namely that there are these two additional methods, set up and tear down, that can be used for any code that you'd like to share between all of your testing methods. So it makes a little sandwich. For each method that you define that begins with the word test, the system will call setup, then test, then tear down. And so, for instance, we could have, if we wanted to, shared an instance of AMAnimal between all of those tests. Simple enough. And it's useful to do this kind of mock thing that I was trying to demonstrate at the end, where we define a zoo that has a known set of salutations so that we can test against it in a reasonable and understandable way. You may find, as you start exploring these things, that you need more complicated mocks. You need mocks that ensure that some method is called, or which are willing to wait for a while. And there are frameworks that help you do this if you look around, and you can also define them yourself. Basically, using this is a legitimate use of NSProxy and of runtime shenanigans. So I suggest playing around with that if you want to define powerful mocks. You can make an object which will forward all methods that it receives to some real target object, except it intercepts some certain set of methods that you define and return some known values for those methods. That can be useful, and you can do that with NSProxy. So we've done the bottom-up testing, but now we're going to have UI, and testing UI this way is not so good. So let's do some top-down testing.
Right there, when you changed your model,
Yeah.
when you changed the class,
Yeah.
you said that one way to fix the test breaking is to change the values in the test case, but you said there was also a better way to do it.
Oh, yes, I'm sorry. Right, so the problem with just changing the values in the test case is that if somebody goes and changes, right, so if I were to continue to use the AMZoo instance, not the AMMockZoo instance, and if I were to use a value that I happen to know the AMZoo instance at the moment is using as one of its permissible salutations, then if somebody went and changed that permissible salutation to be something else later, I would be in trouble. It's nicer to have that under my control. So use the mock thing is essentially what I'm saying. The mock thing is nice. I'm going to stash all these changes that we've just made and switch magically to some code that I've written already. Xcode doesn't like it if you change your branch like that out from under it, so I had to close the project and reopen it. Now we are back, and we are new and improved. We have a feature implemented because I did it while you weren't looking. There's this new interface here, salutation, and it takes not at all the list that I had you just dictate because I forgot it, apparently. So Sergeant, Madam, Archdeacon, His Excellency, fine. Roy Roarington is now successfully His Excellency Roy Roarington. Our feature is implemented. But we haven't tested all of this stuff above the model. Like, this nav controllers are pushing, and we've got some buttons, and we're displaying text, and we want to test some of this too. So we can do that with UI automation. And this is a sort of a second technique that I'll teach you for reliability and testing. How do we do it? We do it with instruments, actually. Instruments is not just for performance, not just for coloring parts of your app bright colors to tell you where you have graphics issues, but it's also for automating things. And it does this with a terrifying robot hand that not test, profile, that I will be very excited to show you in a moment. Terrifying robot hand. We're going to automate your app. So I just went to product profile, as you might do to get your time profile or leaks or whatever. There's an automation one as well. And the app is running, and this thing is moving, and this is not especially useful. To get started with this, you will want to create a script. Now the fun thing here is you don't actually get to automate your app with Objective-C. You're going to automate your app with JavaScript, apparently. So I just went to over here in the corner, scripts, add, create, and we get a new script that has one line in it of dubious utility and an empty text editor. And we have absolutely no idea what to do. There are no indications, but there is this promising looking record button at the bottom that I find kind of exciting. So I'm going to go ahead and press it, and you'll see this spinny wheel here say start capture. And so now we've got our app. So I'm going to record a couple actions that have to do with salutation so that we can then examine the results and reproduce them. I'm going to record the action of tapping on the plus button. Oh, it appeared. Magic. Clicking salutation, choosing general, going back, and just making sure it's getting saved to the list. Well, it's not a very good name, general, but it'll do for now. We could do the typing thing in a moment. So we've got this really simple little script that's been recorded here for this animal that has a salutation but no name. And you see all of these things are helpful little tokens because it's generated the script, but it doesn't really know the semantic meaning of what I've just been clicking on. It's like, is this, do you mean that you wanted to click on whatever happened to be enabled, or do you mean that you want to click on the element that's titled add? So the nice thing to do after you make one of these scripts is to go back through and kind of choose some semantic meaning. Like, the important thing about this first action, which is where I click the add button, is that I clicked a button that was labeled add, not that it was the right button. So I tapped on it. Although you'll note I have an option here of, actually maybe it was very important where I tapped on it. You don't know. It could be. So you see the second action is I tapped in the main window, in the table view, in the salutation cell, and that did a push. And then I tapped on the general cell to choose the name for this otherwise nameless animal. And then I went back twice. Let's go ahead and choose back. That's kind of sketchy. Animals, that's not exactly what we mean. We'll just keep it with left button for now, and I'll show you in a moment how you can make these more meaningful. How do we assert things? Well, first off, you're going to have to know a tiny amount of JavaScript. But that's not so bad. It's an algal language. It's kind of like C a little bit. You know, it's not like we're asking you to write in OCaml or Haskell or something here. So what exactly are you going to be asserting? Well, let's go ahead and assert that there actually is a general cell in the table after we do this action. How are we going to do that? Well, we can do the same sorts of things that are already in this list. We can say, well, let's get the frontmost app. Let's get its main window. Check out its table view. And I'll explain what I'm doing here with table views element 0 in a moment. And then let's look for a cell that says general. If that's valid, whew, mouthful, we're going to say, we win. Otherwise, we're going to say, the general is missing, which would be sad indeed. So I'm going to go ahead and close this app and then press the play button. And a robot is controlling my app, which normally would be a cause for alarm. But we note that this little we win message appeared. So what does that mean exactly? Going back to the script here. That means that the frontmost app's main window has a table view. And the first table view that it has, visible right now, that's what this means, has a cell whose title is general. Is valid is sort of the way that we all check this at the end. And there's a number of other ways that we could specify this predicate, and you'll start to get a hint of them here as you look at these little disclosure things. Not this one, this one. So you can say like, well, let's get like the first table view that has 9 rows, that is enabled, that has keyword focus, et cetera. You can give them names additionally, and that can be really useful. So you see that like this button had a useful name, this add button, and that's because that was predefined for like the little plus symbol. You can predefine them in reasonable names for your app as well. And it's a really good thing to do because in doing so, you make your app accessible. Where it's getting these labels is from the accessibility label. And so it's nice to set the accessibility label to be something useful, not only for your scripting purposes, but then because people with disabilities can use your app more effectively. You can find that setter in Interface Builder. And let's just pick, let's say that this table view didn't have a good name before. And we can name it by choosing table views. Table views cannot be named. Of course they can't be named. Where is my accessibility? Never where I put it. Never where I put it. I'm sorry, ladies and gentlemen. Let's try naming this guy. Are you nameable? Ah! Yes, table view cells are nameable. The moral of this story, the embarrassment that I just suffered, is that not everything is nameable. Some things have predefined names. That's fine. Things that don't have predefined names are nameable by going into Interface Builder and setting their label like so, salutation label, or by overriding the accessibility label method of the class. I think there's also a setter. You can just set accessibility label, but you might want to like determine it programmatically or something. You might like vary with the time of day or the color of the trees outside or something. I don't know. And overriding the getter might be more appropriate for you. So that is how you produce better labels for use in your scripting engine and also for use by disabled people. And this is how you write assertions. It's a little more verbose, but you could certainly write like an equivalent to stassert true, which log passes if it's true or log fails if it's not. And then, for instance, if we were to assert schmemeral is in the list, or better yet, emerald is in the list, we would, I hope, find that the general is missing. And the script waits for a moment, hoping, naively in this case, but usefully in other cases, that that cell actually appears. But no, after a second, it gives up, fails, and helpfully includes a screenshot so that we can later go back to our script, see that this failed, see, oh, we're looking for a cell called emerald, and like when we go back to this log, we can see, oh, that's, well, emerald isn't there. And then hopefully we can come to some better understanding. What's up?
So this works with the simulator only, or can you also automate your device?
I believe it works with a simulator only, unfortunately.
What if you change your salutation? So like general is no longer there. Will that crash now?
No, it'll just fail. Oh, I see what you're saying. So for those at home, what was asked was, say I removed general from the list. If you tried to tap, what would happen? It wouldn't crash. It would actually log kind of a helpful failure. Let's go ahead and do that. And then we have to move along. I'm not convinced that will actually be enough to install it into the simulator. So I've taken the measure of running first stop. OK, so run our script with the missing general. It should wait for a moment. Yeah. And now it's missing. It's missing cells. Oh, and we've renamed the cell now, and so it can't even find that. So this is equivalent to what's happening when you miss the general. Notice that a moment ago when we were in Xcode, as an example, I renamed this cell to salutation label. And so as we were trying to find it in the list with the name salutation, didn't work. Same thing happens with missing general. You get a fail here. Actually, it's an error. It's different from a fail, but equivalently useful, essentially. So this is how you can automate top-down. You can make a robot press buttons in your app and make sure that like the right view controller is on screen. To find this sort of list of things that you can do and examine, because, I mean, what are these functions? Where is this stuff coming from? Check out the documentation for UIA element. Which lists the many things that you can do. You can get all of the pickers in the window. You can get all the progress indicators. You can find the navigation bar. You can get the popover, whatever. So you can use this to sort of drill down through your app. Each one of these returns an array. And you can search through the array based on the predicates, like you were seeing a moment ago, in order to find things. I want to really quickly do a review of this stuff, and then close out. So in order to automate UI, you just use instruments. It has a recording feature in the automation tool, and that's a really nice place to start, because then you can have this sort of template, and then you can make the recording actions a little more specific, and then you can make some assertions about whatever it is that you just recorded. So once you've got that going, you can, if you like, actually manipulate things using the kinds of functions that we were just seeing there. UIA element, there's like a tap function, there's drag and pinch and all these things, and you can call these functions and actually make stuff happen on screen if recording isn't quite sufficient. And once you've done that, you can check out the state. You're going to have to use JavaScript to do that, but you can query the state. You can get the text field of a label. You can get whether something's enabled or disabled, or whether it's on screen. You can try to find stuff. And then once you know the state of the world, you can log fail or log pass in order to sort of print out these green or red flags. And it's nice to label things accordingly, both so that your script is readable and you can say like, well, clearly I'm clicking on the share button because its label is share, and the script says share, rather than I'm clicking on the button that is the second button in the main window, which is like, that script is not going to be very maintainable, and anybody reading it is going to be really confused. So it's nice to use accessibility label to label your views accordingly. It's also nice because then disabled people can use your app. But some people will want to label views with something that makes sense for a script, but which really doesn't make sense if, say, a disabled person is hearing the name on VoiceOver. And in these cases, do not use accessibility label because that name will be read on VoiceOver. Instead, use accessibility identifier, which works essentially the same way, except that it is not read on VoiceOver. It is only used for these internal purposes. So to sum up, all of these tools are sort of not the quintessential unit testing or automation tools. They're just kind of what's around now, and that's going to change. And different frameworks come into vogue and leave vogue. This has happened a couple times even while I've been playing with Cocoa development. There's different frameworks for mocks. There's different frameworks for various things, and also you can write them. None of really what's going on here is particularly magic, so especially with respect to the unit testing. You could certainly write something that does the same thing. And so if you find yourself thinking it's extremely tedious to write unit tests, make it less tedious, and then maybe share it with the world. The end goal here is not, as I said earlier, to write unit tests. It is to make a reliable piece of software and to make your development cycle quick and painless and not hugely embarrassing. So, any questions? What's up?
Can you use the automator in timing performance? So if you want to say like this thing loading this query takes less than 0.3 seconds.
So the question was, can you use the automation script to measure performance? I believe that you can, is the answer. You're going to have to use JavaScript to do it. But essentially what you would do is you would tap this thing, then tap this thing, then type, and then measure how long is it until we see a result. One thing to be careful of when doing that is you remember at the end we were seeing something like where when an element was missing, the script would pause for a second. That's called patience. And so that can really throw off your results if you're expecting things to be there, but they're not, and so the script is waiting for them. But so long as you're not doing automated actions while you're measuring, like if you're just measuring, what's the time between when I tap this button and when like this image becomes visible, then that should work really well.
And how do you throttle the simulator to only use like a similar amount of CPU as a device?
How do you throttle the simulator to use a similar amount of CPU to the device? That's a good question. And it's a complicated one because it's not just that like your computer is faster than the device, it's faster in a different way, right? So I mean, in particular, like the simulator does its rendering in software, and so as opposed to this doing it in hardware, and consequently, like if you're doing a really graphics-heavy app, you might actually find that it runs better on the device than on the simulator. There isn't really a good way to say, simulator, I want you to pretend to be like device hardware, and in all of those interesting idiosyncrasies, unfortunately. What's up?
Can you test network very easily with the, I guess with like the automated UI testing, or is it important to mock it out when you're trying to test things that connect to the network?
I think the testing network stuff is something to be pretty careful about. It's good for an integrative test. So like if what you're trying to do is write a test, and I think everybody should have this, that goes down like your list of bullet point features that you talk about and say like all this stuff actually works, broadly speaking, before I ship it, or at least the app doesn't crash when I go to that part of the screen, then yeah, I think it's cool to be using your live servers and have an automation script go and play with those things and just sort of roughly test them out. I think that that's like not especially maintainable to do for detailed testing, because server goes down, and now you get an email from your build bot that says, well, the unit tests are broken, and actually they're not. The server's down, but now all the developers in your team are like, oh my gosh. Or worse, and I've seen this happen, BuildBot sends that email, and all the developers in your team are like, well, whatever, it's always sending those emails. And so they pay no attention, and now you've got the boy who cried wolf, and then the test actually breaks, and nobody pays any attention. So I think it's OK for rough testing is the answer. And you should mock it out for a detailed answer. And that's a really good example of where using mocks is great. You're doing network stuff, just like make a version that gives the answer locally. And then you can test how things work without network traffic.
For more, please visit us at stanford.edu.